Department of Computer Science and Engineering, Sri Sairam Engineering College, Chennai. Over to you, ma'am.
Okay. So, good morning, one and all present here, all the participants and the faculty and the people who are working in Sairam Engineering College. Good morning, all of you. Any response?
Yes, ma'am. Is it audible?
Yes, ma'am. It's audible, ma'am.
Okay, let me share my screen to do with my presentation. So, sir, please enable the sharing option, sir.
Yes, ma'am. Enabled, ma'am. It's enabled, ma'am.
Okay, let me check once again. Yes. Once again. Okay. So, can you able to see my screen, sir?
Yes.
Can you able to see?
Yes, ma'am. It's very clear.
Okay.
And your voice is also clear, ma'am.
Okay. Once again, sir. Once again, be online. Once again.
Sure, ma'am. Participants, kindly mute yourself for the whole session, and then there will be a question and answer session. You can post your queries in the Zoom chat box, or you can ask madam by unmuting yourself.
So, yes, shall I proceed, sir?
Yeah, ma'am, please.
Okay. So this is my topic actually, the machine learning in IoT. So sir has given a elaborate information about me. I'm Dr. Parvathi, working in Vellore Institute of Technology, Chennai. And I will just make it as a full screen. Can you able to see?
Yes, madam.
Yes.
It's in full screen mode now.
Okay. So already for this past 1.5 days, you might have come across with the terminology called as Internet of Things. So first, let me give a brief about this Internet of Things a little bit, as well as how the machine learning algorithms can be incorporated to improvise the Internet of Things performance and the efficiency. Later on, I will just give my one research work which is going on under my guidance. I'll just project it. This is what my agenda of this today discussion. So the Internet of Things is nothing but a combination of embedded technology, which includes the wire as well as the wireless communications, sensors, activists, and the other physical objects which are connected to the internet. So this all together will be considered as an Internet of Things. Obviously, the data which are generated from the Internet of Things, or what are the data which are used in the Internet of Things. IoT requires a data either to represent for the better services to the users, or to enhance the performance of that IoT framework to get the intelligent output. This is the main objective of the data. So the data is valuable in the Internet of Things. System access the raw data from the different resources over the network, and that will be analyzed. That information will be used to extract the knowledge. Obviously, the raw data is going to be analyzed and it is going to be processed as a knowledge. What is actually this? Since the IoT will be among the most significant sources of new data, obviously, the data science is going to play a vital role in or considerable contribution is going to be taken place into the field of Internet of Things applications, which will give you the more intelligence performance applications. The data science is nothing but a combination of data mining, machine learning, and other techniques like pattern findings, finding the new insights from the data. So as a whole, what I want to say is Internet of Things is performing, is intelligent, is one thing it is going to perform intelligent. And this data is more important. Once the data is perfect and the model can be working on the data, then your performance, IoT performance is going to be increased. So what are all the main components of that IoT? Obviously, you might be knowing about all these things because you are learning from past 1.5 days. It consists of sensors. The sensors may be a mechanical or electrical parts. Processing networks. We used to name it as a ports, antennas, as well as a protocols. And we have an analysis part over there. This analysis, data analysis component is going to analyze, or it is going to make an analytics to the trained data and run on the different models. It may be the AI model or machine learning model or the deep learning models at the each node. Edge, obviously, it is considered to be the node. Edge is nothing but a node. And the last component, in brief, it's a system monitoring, how the data is going to be stored, as well as what sort of software you are going to make it for this IoT framework. So these are all the 4 main components of this IoT. And similarly, communications in the IoT is going to be having 3 categories: device-to-device communication, device-to-server communication, or server-to-server communication. Device-to-device communication, in the sense we are going to name implies it's very common. Communication between the 2 devices, nearby devices. It may be the mobile phones. Device-to-server communication. It is nothing but the data which is sent to the server, which can be close or far from the devices. That means that the data, it is coming from the device to be transferred to the server. The third category, name implies that server transmit the data between the other servers. So either type of communications we can implement in the IoT. So a common characteristics of the data which are used in the IoT, obviously it's a big data. IoT provides or IoT produces the high volume of data, fast velocity of data, as well as the different variety of data. So these are all the, normally now 5 V's are available. At the beginning, big data talks about the volume, velocity, and the variety. So all these things should be carried out with the help of the IoT. Hence, it is very difficult in the IoT as well as the big data. It is going to be a challenging task to preserve the quality of the data, because at the large volume of data is coming at the large speed rate, and the variety of data, it is also coming over there. So we need to maintain the quality of the data with respect to the big data or whatever it is, IoT, whatever it is. So similar, the data is coming from the different sources, sensors, social network, many things. So it is coming from the different sources, and it is mostly not processed. It is a raw data only. We need to process it with the help of the IoT devices. So it is, we need to do some pre-processing work in order to send to the IoT devices or the embedded devices. That we need to take care. The pre-processing is also a major challenging with respect to the data, which need to be handled in the IoT. Obviously, these are all the applications you might have come across. IoT can be used in the retail. Obviously, so it can be retailed, it can be used in the retail for the purpose of dynamic pricing. If my voice is breaking, you just inform me. Is it audible now?
Yes, madam. It is audible.
Okay. So if there is a problem, you just inform me. Otherwise, we may not know it, right?
Sure.
So obviously, these are all the applications with respect to the retail dynamic pricing, smart supply chain, precision demand forecasting, and in terms of marketing, we'll be making use of the ad campaigning. What is the best offer we can provide? What is the next best offer we can provide? When we are dealing with the smart highways, we can check it out with the help of the IoT, like monitoring the vehicles, weather with respect to the travel and the road conditions as well as the closure. Similarly, precision traffic, especially self-driving car, self-parking with respect to the connected cars. Then we are very familiarized with the smart city. What is that growth of the smart city? Dynamic street lighting, smart energy usages, all these things. Not only this, many things are available with respect to the applications. Healthcare, obviously wearable, personalized medicines, patient provided monitoring, and we are going to have that online education also, personalized learning and real-time interventions. Then you can be come to the forest, farms, vineyards, like a precision planning, nutritioning, harvesting, how we can do all these things. Obviously, in all the fields which we can go ahead with that, financial companies, marketing, banking, as well as the insurance, with respect to the risk mitigations, fraud detections. These are all the more important things when we are dealing the IoT applications with respect to the finance, banking, insurance, and all these things. Similarly, we'll be going for the one of the important thing called as the invisibles. Invisibles in the sense like we can go ahead with some acting, having some sensors under the skin, smart sensors, which can be not only is going to measure, it also going to learn, react, and proactively respond. This is a one thing called as the Internet of Emotions. Like that is a inbuilt sensors which are going to be accommodated in the human being, and based on that it is going to learn the emotion, it is going to react with respect to the emotions as well as proactively respond to the type of the emotions which the human being are having. And these are all the different applications which we have over there. And this is the simplest architecture of the IoT, which we are going to, which we can, or enhanced version of that architecture is also available. This is a basic model of the architecture which we have. Obviously, we have sensor over here, and we have a gateway. The next one is a gateway. Then that the sensors, the data which are coming from the sensors, which is passing through the gateway, and that is going to be available on the cloud. Then that is taken care by the data processors, that will be handled by the data lakes. Obviously, it is going to be taken care of the big data warehouse, where we can go ahead with the machine learning algorithms that can be applied on this data warehouse. To get, we can design some models. We can design some models with the help of the machine learning, and we can make some control applications, and we can control the data which is available on the cloud. So this is a basic architecture. When we are dealing with this machine learning, this is the one framework. Suppose if you are going to use some web applications in the sense, this is another framework which we are going to do it. Taking the data from the big data warehouse, apply some user business logic over there with the help of the web applications as well as some mobile applications. The data are going to be combined together with the help of some business logic, and you will be getting the output as some analytics. So it depends. This is the total, this side, this vertical is called as a device administrator. This application, this vertical is called as a user administrator. The next one is considered to be the last one is a security monitoring. So this is about the architecture we have. And this is what I have told you. What is the purpose of the device? Device is very simple. It is going to have some sensors. That sensors will generate the data, which can be transferred through the network, and that can be used to analyze some of the operations, that can be used to allow the things to do according to the instructions. Like we can say that switch on, off the light, open the door and close the door, increase and decrease the engine speed and all these things. Similarly, the second part, which we have said as the gateways, the data which is coming from the device is going to be transferred to the cloud via the gate. So the gateway provides a connectivity between the things and the cloud as a part of the IoT solution. Obviously, this is a gateway. Then the cloud gateway, what it is going to do is going to do the data compression and it's minimum ensuring the data transmission between the gateway to the cloud service. So the cloud gateway is going to do the servicing of data compression as well as a secure way of transmitting the data then and there in the environment. Then what type of data processing which we are going to do is like it is like a effective transitions of input to the data lake. I'll tell you what is actually the data lake and to the control application. So the data processor, it is going to be taking care of that, no data should be corrupted or lost. That is the main duty of the data processor. And when we are dealing with the data lakes, in a sense, it's like a storing of data over here connected to the devices, obviously, which we are going to do with that. So the data lake is going to store the data generated by the devices in a natural format. That is more important. That is one important. The data may be of massive data or the stream data. Hope you know that what is actually the massive data and the streaming data. Streaming, normally the embedded environment, streaming data is going to be handled. Handling the streaming data is a very difficult task instead of handling the static data. Similarly, massive data, IoT, this is the sensors and all, it is providing a massive data, large volume of data. So combining the massive data as well as the streaming data, it is a major challenging to handle this. So from this, what we need to do is we need to find the insights. What is the impact which is available on the data? So all the data which are going to be stored in the big data warehouse for the future processing, and it is going to be cleaned in the big data warehouse, some sort of pre-processing mechanisms which we are going to take it out over there, some sort of pre-processing mechanisms. What are all the pre-processing mechanisms? Data cleaning, we are going to take it out over there, and we are going to make the structuring of the data as well as the different pattern matching of the data which is going to be handled over there. And obviously, data analytics, it can be performed to find out what trends it is needed, what is actually the gainable insights which are available on the data which is available. So this is about the general architecture of the data which we have over there. And similarly, we have one more thing called as the control applications as well as user applications. This depends upon the software. These are all the automated softwares or the user-defined applications, which are connected to the IoT devices in order to monitor and control the smart things, especially say for an example, user applications in the sense, depends upon the specific applications like a car automations, home automations. And similarly here, control applications in the sense with respect to the automatic commands which we are going to make it over. See, all these things automated in the sense, say for an example here, you just check it out with that. Whenever you need to, when the sensor shows that the soil is dry, the watering system should be automatically enhanced, automatically switch on that. This is what actually the control applications. Either it may be of either control applications or the user applications. So it depends upon the applications which we are going to make use of. Now coming to the point. machine learning. What is actually the machine learning? For why it is required for that IoT. So the machine learning is used to help analyze the massive volume of data in the sophisticated, with the help of the sophisticated algorithm to improvise to find the hidden patterns which are available on the IoT data. So that is the main purpose of making use of the machine learning algorithms. It can supplement or replace the manual processing with the automated systems, statically derived actions in the critical purposes. Like normally, what is the thing is like the critical process. The critical process is a more important terminology which cannot be handled manually. That is considered to be the critical process. So, which machine learning which we are going to do is that we are going to analyze the volume of data. We are going to create a model, and the model is going to assess the data, and appropriately it is going to give a decision, or it is going to be performing, depends upon the data. So how the way the machine learning algorithm help? Actually, the machine learning algorithm can help with respect to the class discovery, can do with the correlation discovery, can do with the association discovery, or with respect to the novelty discovery. So what is actually the class discovery? How this machine learning algorithm is going to do? Like it is going to find out the new classes of objects, events, behaviors that is considered to be that class discovery. Based on some rules, we are going to find out some classes boundaries. We are going to define based on the rules, conditions, constraints. We are going to define some set of classes. Based on that, we will be pointing out these are all the constraints for this particular applications. Similarly, correlations can be implemented with the IoT. What for it is the correlation is going to be used. The correlations which are going to be used to find the patterns and the dependencies. So how the two variables or how the two data are going to be dependent, and what is the dependency between these two variables which are available. And based on that, we can go ahead for the new revealing the new governing principles or the behavioral patterns. So one best example is considered to be the DNA analysis. So based on the patterns which is existing in the DNA, we can find out what is the new patterns or the behavioral patterns which are found with respect to based on the correlation risk. Similarly, we can go ahead with the association. Obviously, we know what is association based on the co-occurrences of the event, or we can say that if we have this happens, if it is happened, what can be happen? That is a thing called as that association. What can be done? So association discovery is that finding unusual co-occurrence of associations. And now come for the novelty discovery in the sense, obviously novelty in the sense finding new. From the, or finding the rare one, or finding a 1 in a billion or a trillion which are available as an objects or the events. Finding a new object, finding a rare object, finding a 1 in a million object, that is considered to be the novelty discovery. All these things, what are all the things which we are going to use? So from this, whatever the thing we have discussed, class discovery, correlation discovery, association discovery, and the novelty discovery, all these things are coming under our machine learning algorithms or the data mining algorithms. We can say that the class discovery is coming as a clustering, which is used to find out the new classes or making the segmentations. And we can go ahead with the correlation and the association link discovery. Obviously, we have a separate correlation as well as our association rules are available. Similarly, predictive discovery in the sense we can go ahead with the classification diagnosis, we can go ahead with that. And we can go ahead for this novelty discovery in the sense of finding new and anomaly detections. All these things can be done with the help of this data, or the machine learning algorithms can be incorporated in the IoT. So normally we will be having, these are all the basic concepts. Machine learning is categorized into two. One is a supervised learning, another one is a unsupervised learning. Yes, you know all very well about the supervised learning. The majority of the practical machine learning uses the supervised learning algorithm only. The supervised learning algorithm is nothing but mapping function approximated from the past experience. We have a two supervised major category called as a regression and the classification. So here f of x is equal to y is going to be the real number. Classification, y may be of a categorical variable. That is yes. So the regression, any problem with that? Pardon?
Participants, kindly mute yourself.
Okay, no problem, no. So
Madam, you can carry on, madam.
Okay. So regression, we have dealing with the supervised learning, which is dealing with the real numbers and the classifications. Obviously, the category labels, which we are making use of that. What we are doing in the machine learning, supervised learning, in the sense we are training the labeled with the positive as well as a negative examples. And from the training, we are going to give the unseen input and predict a corresponding output. So we made a training over there with respect to the positive as well as a negative example. From that, we are going to give an input and predict the output. So this learning process is going to be continued until your performance is achieved, your acceptable performance is achieved. This is about the supervised learning. Then come for the unsupervised learning. This is very simple, discovering the hidden patterns or the hidden relations which are available on the data. One of the best example of this unsupervised learning is a clustering. Obviously, it is going to cluster the objects into the set into the different distinct subsets. And similarly, we are going to find out having the algorithm called as an association algorithm. And it is going to find out the relation between the pattern of the data which is available over there. So what is this thing we are doing compared to the unsupervised learning, in the sense only we are going to take only the positive, no negative training is going to be given. No labeling is going to be taken place. Will not assure that only one single answer you will be getting it out of this unsupervised learning. Multiple answers you will be getting over there. So what is the practical usage of this unsupervised learning, in the sense, especially clustering, deriving the group, not based on the explicit labeling, but classification we need to make it as a explicit labeling, we need to make it out to make the group. This is a difference between the supervised and the unsupervised learning. So here, what is a thing I want to specify is like here at the lower level, we have the things, devices, sensors. That is what we are saying that as edges. And this data which are generated with the edges, which are going to be carried out with the help of the edge computing. And this edge computing, normally what it is doing is data analysis, data element analysis, and the transformation. Data analysis and the transformations we have been doing here. And all the part of data transformations we are taking over here. And this data ingestion is nothing but transferring the data which are available from the devices and making into the cloud for the data analysis. That is what called as a data ingestion that we are going to do. We need to do over there. And obviously, we need to perform the data analysis, and that is going to be carried out with the people process. This is actually the example of IoT data analytics architecture. So the data which is connected from the devices that should be transferred to the cloud, and it is going to be taken for the application after the data analysis process is over. This is a basic example. What is the same thing only I'm projecting here? In this location only, this place only, between this data analysis and the application only, between this area, either you can go ahead with the machine learning, or you can apply any type of models which belonging to the machine learning or the deep learning models can be incorporated to enhance the performance of the IoT devices. So here, the same thing, data analytics in IoT with the machine learning is one example I'm specifying here. It's here the data which I have taken. It's like a static data. It's like a static data I'm taking over here, and it can be stored in the data storage. It can be stored in the data storage, or you can take it out of the streaming data. Yes, you can take anything like streaming in the sense based on the time series. Continuously supplying the data. It's say for an example, electricity data or the stock market data or the machinery data or whatever it is, chemical data, whatever it is the data which is taking, that will be considered as a streaming data. That is going to be given as an input to your model. What the model you are going to have here, machine learning model, which is going to be here. So what the data, this pre-processing technique, streaming model execution. So what we are going to do is whatever the data which is extracted, that should be pre-processed. Then it should be taken into the into your data storage. From there, you will be getting the models. This model should be trained, it should be tested, and it should be verified or monitored. All these things should be carried out with respect to this machine learning or your AI, whatever the models you can do it and deploy it. And appropriately, what you can do is you can give the alerts and the reporting decisions you can give to the devices accordingly, or to the visualization purpose. This is just a framework of the machine learning, how it is going to handle the data. So when obviously, which we have discussed, we are dealing with the machine learning. What are the things to be considered? Since it is data is generated from the different sources with the different specific data types, we need to adapt or develop an algorithm. That is more important. Choosing the algorithm, taking the algorithm, developing the algorithm to handle that the particular data characteristics. What type of data we are taking, that accordingly we need to take it out. Suppose if you are taking the categorical data, better obviously you can go ahead. I will be suggesting all the things in the forthcoming slides. So say for an example, if we are going for the supervised learning, if you are dealing with the regression analysis in the sense, obviously we will be going for the real-time data, real numbers. And if you are going for the classification in the sense, it is like a categorical model we are making, the class labels we are going to make use of it. Depending upon the data only, we need to choose the algorithm. And we need to take the algorithms in such a way that you should not suffer the scalability and the velocity. That is also an important consideration. Similarly, we need to find out the best model of, we need to choose the best model that fit the data in one of the important issue of the pattern recognition, or to go for the better analysis of the IoT. So what I mean to say from this slide is like, first understand the data, then choose the algorithm and deploy it in your IoT devices. That is the thing I want to specify. As an example, you might have come across with the smart city applications use cases. As an example, I'll just go ahead with this machine learning algorithms. What are the machine learning algorithms which are available? and what purpose it is there, we can go ahead with it. What is the purpose of this each algorithms? Like, let us take the linear algorithms as a classification, support vector mission, or the regression algorithms. Classification, it is going to be linearly separable with this, like the classes are separated by the straight line. Support vector mission in the sense, we can not have a straight line, we can have a wide gap instead of the straight lines. Regressions will be having the relation between the variables and the elements. It is going to be making the linear relation between the variables and the elements. Non-linear algorithms, like take an example of a decision trees and jungles. It is going to divide the space into the regions. That is the thing which is going to be done with the decision. Then come for the neural network. It is making the complex, and we can go ahead with the irregular boundaries of this data, which can be handled with the help of the neural networks. And special different algorithms, ordinal regressions we have. This can be when your data is at ranked values, better to choose with the ordinal regression. And if you can go with the distributions, if you want to count the number of things, Poisson distributions will be preferable. Discrete distribution is preferable. Then Bayesian distribution, normal distributions, you can get the bell-shaped structure. Like if you have increase lower to the higher, higher to the lower, then the Bayesian curve or the distributions can be used. It is a limited algorithms only I have specified. So depends upon the data or the depending upon the outcome applications which we are going to make use of that. We need to choose the appropriate algorithm. So as a part of that, I will just give you in this paper, they have handled this use case called as a smart city use case. You know very well what is actually the smart city. So the smart city depends because of the population, because of the infrastructures, cities need to be handled more carefully. Large scale urbanization problem is available. To play this, because of this infrastructure as well as the population, IoT is going to collect the data from the city environment. And this IoT enable the city to use the live status about the reports and the smart monitoring systems, which can smartly react with the emergency situation or emerging situations such as earthquakes and the volcanoes. And this IoT technologies, if you are incorporating in the city, the majority of the city assets can be connected to one another and making more observable and easy to monitor as well as manage. So you know very well about what is actually the purpose of the smart city. The many applications are there with respect to the smart cities to improvise the services like traffic management, water management, energy consumption, as well as the quality of lifestyle of the citizens also. So what is the objective? The smart cities, it will transfer the rural to the urban areas into the place of more democratic elections. Therefore, what we can do is we can decrease the expenses in the public health, safety, and transportations. So this is the main objective of the smart city. So in this way, we can achieve the smart city by incorporating the smart energy, smart transportation, smart citizens, smart planning, as well as smart data. So I'm not going to give a more aspect of all these things. I'll just go through all these things once. Smart energy. What is that actually the smart energy? Obviously, it is mainly used for the main application. Is a smart energy applications are smart leak monitoring and renewable energy resources. See here, this is like the main objective, main application is that you can take it out as the water leakage or the gas leakage management can be done with the help of this smart energy management. As well as what we can do is all the data which we are connecting is considerably mainly taken into the consideration as a time series data. So IoT directly mingled with the time series data. So we need to know the mechanism of dealing the machine learning algorithms which are directly dealing with the time series data handling. Similarly, smart grid applications also. So this is about the smart energy and the smart mobility. The second one is the smart mobility. All we know about the automated cars or the autonomous cars. Here, what they are going to do is it is going to create a self-driving car and it is going to give the vehicle performance. Whatever the data which is collected from the vehicle, that can be taken for considering the most popular routes as well as the congested routes can be predicted, and the decisions can be taken accordingly to decrease the traffic congestions. And the self-automated cars can be enabled to make the surety of safety of the passengers also. So these are all the smart mobilities. And the smart mobilities, we have this traffic control. Obviously, the traffic data will be collected from the number of cars which are available, number of roads, number of cameras which are used, and what are the sensors which are installed on the roads. All these things can be collected in order to minimize in order to control the traffic also. Then the public transportations is another smart mobility is there. So what it is going to do is it is going to assist the passengers to make the better decisions in their schedule as the decreases the number of wasting of times. Like I want to go from here to there, in the sense accordingly I can schedule, and with the shortest distance and the number of buses I have to transfer from here to there, so that I can minimize the time over there. And we can find out the vehicle locations data as well as the traffic data with the help of the public transportations. So this is about the public transportation. Obviously, next one is smart citizens. Yes, here we are going to make covering with the human lives. So such as environmental monitoring, crime monitoring, and the social health. So all these things which are coming with respect to the smart citizens, how we can make with respect to the avoiding the crime, and how the environmental security we are making over there, all these things coming as a smart citizens. Similarly, urban planning also, because we need to take a room, or we need to design the infrastructure, city infrastructure, planning the infrastructure properly, design the infrastructure properly. That is what called as the urban planning. The IoT is very beneficial in this area, because smart city data are analyzed. Accordingly, we can predict which part of the city can be used, which can be more crowded in future, and how we can potentially solve this problem. So a combination of IoT as well as urban planning, which is considered to be the good solution for the future infrastructure development. So yes, this is the all components which we have discussed. Whatever the things we have discussed as smart energy, smart transportation, smart citizens, all these things, quality of the data. So when we are going to design a model, the data first should be analyzed. So the quality of the collected data is more important, particularly smart city data as an example we have taken over here, because they are collected from the heterogeneous sources, not from the single sources. So the quality of the data may be affecting the three factors. One, in the error in the measurements or the precision, how precisely we collected the data, how correctly we measured the data. That is more important. If we made any mistake on collecting the data or measuring the data, definitely your IoT framework will not give you the correct, accurate result. And the second one is device noises in the environment. So obviously we are collecting the data from the devices one. So how we are going to eliminate these errors which are generated from the devices. And the third one is that discrete observations as well as the measurements. So the discrete measurements, that is more important. It's a real time in the sense, in the time series data in the sense, just continuously it is coming over there. So how we are going to make it how the quality of the data we are going to consider it by considering these 3 points. And to achieve the better quality of information, that is what called as a QOI, it is necessary to extract a higher level of abstractions and provide the actionable information to the other services. So higher level abstraction it is needed, higher level abstraction. So we need to deal with respect to the data, metadata, all these things we need to get it. High level of abstractions we need it. So the QOI is smart data. In smart data depends upon the application and what the data characteristics, what type of data which we are going to take it over there. So say as an example, this is about the smart city. We have talked about it, and what are the problems with respect to the data you may get it. And now we are going to see about the use cases, machine learning implementations they used in the smart city use cases. So here the smart city use cases they have taken and what type of data they have used and where this data is going to be processed. That is an example. So as an example, if we are taking the smart traffic data set, in the sense it may be a streaming data or it is a combination of streaming data as well as a massive data. And in the edge level itself, in the sense node level itself, we need to access it. We need to process it. Similarly, a smart health data, here also it is a streaming or the massive data. It can be processed in the edge or the cloud level. And the smart smart environment, same thing. Environment in the sense, because it should be handled only the cloud, not in the node, because it should be the environment. So it should collect with respect to the different nodes. That is a one. Then smart weather in the sense, it is like a streaming data. It is not a massive data because it's a weather. So it should be handled with respect to the edges. Maybe asking, ma'am, why we should not handle at the edge level itself. Yes, you can do it. But if you want to have it with respect to the cloud, you will be incorporating with respect to the different environment, heterogeneous data. We are taking over there and deploy it in the cloud so that your IoT data is going to be a valid one, not without any flaws. And here the smart citizens, obviously it should be handled in cloud. It's a streaming data. Smart agriculture, streaming data. It can be because it is like a edge-wise analysis or the cloud-wise analysis. You can make it over there with respect to the agriculture. Then smart home. Here, massive and the historic data. That is more important. Not dealing with the streaming data. Because if I'm going to make a smart home application in the sense, we need to take the consideration of the historical data also. So there is no need of making the smart streaming data over here. So this is to be handled in cloud. Smart air control, also dealing with the massive and the historical data. Smart public place monitoring, only it is dealing with the historical data and it should be processed in cloud. Smart human activity control, both streaming and the historical data. Human activity. So it depends upon my previous activity. The thief can be easily identified based on the previous history, and they can be lightly accessed what are the problems which is created by the particular person. So these are all the type of the data which can be used for the different application. This is the first perspective which is analyzed in the smart city use case. Then here is an overview of the machine learning algorithms which can be used for the different applications. Machine learning algorithms which are used. Like say for an example, if I'm taking K nearest in the sense, that is a classification algorithm. Navy bias is also the classification algorithm. Support vector mission, I can go ahead for the classification. Linear regression, it is a regression algorithm. Support vector regression, we have one more thing, that is one called as a regression. Then classification and regression tree, both the things, classification and regressions can be random forest, obviously both can be combined. Bagging and boosting can be combined with for the purpose of classification and the regression. K-means, obviously we know clustering. Density DB scan, it is a clustering algorithm. Principal component analysis for the future extraction, and canonical correlation analysis for the future extraction. Feed forward neural network is meant for the different applications like the regression, classification, clustering, feature extractions. All these things can be done with the help of this feed forward neural network. And one class support vector mission is mainly used for the anomaly detection. One class support vector mission mainly for finding the novelty, or the outliers. Anomaly detections can be done over there. So what is this actually, this statistics is giving you the most frequently used machine learning algorithms for the smart data analysis. So we have the data processing task, what are all the tasks which we are having, and what type of algorithms can be used for this particular data processing task. And here is another statistics which is available for this, especially we have meant for this machine learning algorithm, what we can use, and what type of use cases, smart city use cases, what type of smart city use cases can be applicable for that particular type of machine learning, and what is a metrics, or what are the things we can do with respect to this particular machine learning algorithm. Say for an example, if I'm taking the classification in the sense, I can do with respect to the smart traffic analysis. So from this, I can find out the traffic prediction and the increased data, whatever the where the more congestions are occurred over there. And when we're dealing with the clustering, this clustering process, smart traffic can be analyzed, as well as a smart health can be analyzed. So obviously, this is meant for the clustering can be used for many applications. One such applications are that smart traffic and the smart anomaly detections. We can go ahead with that unique nature of this traffic or the car or the vehicle behavior, and the smart environment. Finding the anomaly in the power data set, that is most important. Then the support vector mission, obviously meant for the weather predictions. So support vector missions is meant for the forecasting purpose. Similarly, linear regression for finding the correlation or this economic conditions, market basket analysis, and the energy usages. Say for an example, real-time predictions, what is that economic level, and here we can have with respect to the classification and the regression models. Both the things can used to find out the smart citizens, and the travel pattern of that particular smart citizens can be used for this using this method. Especially one thing, the support vector mission is meant for all the use cases, that is preferable for all the use cases, that will categorize the data, that will classify the data and do the real-time predictions. So we have another thing called as a K nearest neighbor algorithm, because who is nearer to me and what type of person I am and what type of person he is. Sometimes that is a thing, the smart citizens. Smart citizens patterns we can easily find out. And based on this, we can find out the travel pattern of the persons who are nearer by. That can be done over there. And the bias algorithm, it is as a classification algorithm. Using this classification, we can easily go ahead with the smart agriculture as well as the smart citizens and all these things. We can take it out over there. So say it is a continuation only. K means clustering. Based for this, but it is best for this smart city, smart home, and smart citizen controlling air as well as the traffic. And density based clustering, especially for the smart citizen analysis. And feed forward neural network, we have done it with respect to this smart health. And the principal component analysis meant for the public places. Canonical correlation analysis is also monitoring the public places where you can easily find out the fault detections. Who is doing the mischievous actions or abnormal actions which are carried out in the public places. Then one class support vector mission is meant for the fraud detection and identifying the outliers, like novelty or the unique activity which is carried out over there by the particular human being. So this is about all with respect to that different applications as well as the algorithms which are used and the different data sets can be assessed and where it can be processed. These are all the papers I refer to make this PPT. Now, I will just go to my work, which already I have done it with my, what to say about it, scholar. I will just share my work, what it is done over there. Yes, can you able to see my screen? Can you able to see my screen?
No, madam, no.
No,
It's
madam.
not
No,
visible.
madam.
It's not
No?
visible.
Okay,
No,
one
madam.
second. One second, one second.
Okay, okay.
Now, is it visible?
No, madam. No, madam.
Okay, one second. One second.
It started screen sharing.
I shared the screen.
Yes, we are starting.
Resume share.
Yeah, madam.
Resume share. Resume share. Is it now? No, I'll make a new share then.
Okay, okay, ma'am. Okay.
Now?
Now
Yeah,
it's
ma'am.
visible, ma'am. It's visible
Yeah.
now.
Okay. Okay. So here, what we have done is like what is a pattern of walking? What is actually the pattern of walking by a particular person? So the new novel algorithms, not novel algorithms, we combined the existing algorithms and we analyze the features which the human being based on the walking style. That is what called as that gait analysis. So in this case, what we have done is like we identified the human and we categorize them based on their walking style, based on their walking style. This is the one which we have taken over there. This type of walking styles mostly useful in the case of many applications, like the defense applications, medical applications, video surveillance applications, and all these things. Here we have done with respect to the number of sensors. such as MEMS sensors, accelerators. These are all the gyroscopes, pressures, positions were deployed for the measuring of different gain signals from the body and analyze the human behavior. So we have the sensors and we get the signals, and the signals based on that we are going to analyze the behavior of a person. Now, this is the most important useful application for this diagnosis and the classification, obviously. And here, what is the different algorithms? Already, even I to frank with that, different already existing algorithms we have executed, and we identified some of the algorithms is better performing best. And let me conclude it with that. What is the thing we have done is like we have carried out with this experiment with the 35 individuals and with respect to the 16 parameters were recorded and analyzed. As an initial level, it is very minimum only. I do agree with that. And we applied with the different learning algorithms because we need to handle more number of features. That is the more important thing, as well as some more number of data, that not only 35 individuals, we should have more number of data that should be captured. And here, what is a real-time data collection system which we have used is like the system we have connected with the 5-volt battery with this board integrated with MCB and MCB 3008. Which is used to measure the data which is collected and stored into the cloud. And the system is equipped with the 4 MEMS accelerated and 2 force sensors like foot sensors and 2 flex sensors, 1 gyroscopes. These sensors are going to measure the pressures and axis movements, and the axis movements in the sense knee movements of the participants depends upon this movement, and transmit this data to the cloud via this Wi-Fi transmitters. This is a model which we have used. This is some pictorial representation of the sensors models which we have used in the gain measurements. And similarly, what type of cloud storage we have used, and different MEMS and the flux sensors which are used over there. These are all the just for your observation. And based on this environment, based on the environmental setup, we collected the gain features from the different sensors and which are mounted with the 35 subjects. Subjects is nothing but the users, say for an example, objects or the human being. 35 human beings and between 20 to 40 years of people. And the data were collected while they are walking for 5 minutes, and nearly 15,000 to 15,000 odds individual steps were calculated. These data are considered for this pre-processing and utilized for the future extractions. And this is from this data what we have collected, we have categorized them into the spatial, temporal, and the kinetic features we have calculated. The 16 features I said, the 16 features I will point out later, collected from this IoT environment. 7 features are, we said that as a spatial, temporal, and the 9 features we have taken as a kinetic features. And this is the details of the features which we have. Only 14 it is displaying, remaining 2 it is coming down over there. So these are all the different features. Just to make a glance out of this, I'll give you 1 minute of time. You just it's like a pattern of walking which we are making over there. So totally 16 features we have taken over there, and this is the architectural diagram which we have used. Now, what I'm saying is In this portion only we need to apply our algorithm. This is the algorithm. Either it may be the machine learning algorithm or the deep learning algorithm, whatever it is. This is totally your IoT environment. You are going to collect the data over here. This is a collection of data. So this is a collection from the sensor, data collected from the sensors, and we are measuring from that, storing it into the cloud and transforming the data to the algorithm. So the two different algorithms we have used, one is called as a wolf algorithm, another one is called as a blue whale algorithm we have used, and we made a classifiers. We made a classifier algorithm, that two algorithms are the classifier algorithm. Based on that, we categorized them into the different pattern of walking, how the people are walking, what is a walking style of the people. Somebody may be bending front and back or whatever the stretch position and all those things. So we have taken like the spatial temporal features and we got the different applications we tried out with the existing application. And I need to say that the different existing applications like support vector emissions, linear method, Gaussian method, polynomial method, and extreme learning methods we have done it. Similarly, K nearest algorithm, random forest, neural network. Pardon?
Participants, mute yourself. Participants, kindly mute yourself. Madam, you can start. Sorry, madam. Sorry for this.
Okay. No problem. So what is the thing we have done is like we calculated we made the different machine learning algorithms. We made it. Obviously, we find out some of the efficiency parameters like sensitivity, accuracy, and precision, specificity. All these things we have find out over there. And obviously, we came to know that according to our application, because of the smaller data only we are taking over there. So it is saying that it is only the extreme learning algorithms, extreme learning, it is performing better than the existing algorithms. This is the conclusion we have done it over there, and we calculated the we applied. Yes, obviously, what I mean to say is all these things algorithms we applied to the different classifying algorithms, different classification algorithms, and we find out the best model over there. What is the number of classifier models, different visualization purpose we have done it over there. So this is my contribution related to the IoT as well as the machine learning algorithm. The one thing is like I cannot say that this is the best model in the machine learning algorithm. This is the best model in the machine learning algorithm. I cannot say that. Depends upon your application only. We need to work it out. Depends upon the data only. We need to choose the algorithm properly in order to make your framework in a better performance. So this is about from my side. Any sort of questions, if you have, you can raise.
Participants, you can post your queries. The session is open now. Or you can post your queries in the chat box also. Madam will answer. Participants, you can start asking questions. Chat window is also open. You can post your queries in chat window also.
Thank you. So one message has come from 163. Good session.
Yeah,
really
good
appreciate.
Really appreciate. Yes, ma'am.
Yes. Okay.
Good afternoon, madam. Hello.
Yes,
sir. Please go ahead, sir.
Madam, have any idea about the surveillance applications using the IoT?
You want to talk me related with the IoT or machine learning?
No,
Because
Sir, in the surveillance, whatever the IoT with the machine learning, madam. Actually, I am also research scholar. I want to do in that.
yes. I will just tell you something like machine learning perspective. So vigilance is like a classifications. You can go ahead. You can try it out with the support vector mission. You can try it out with that. If not, you can directly go to the deep learning models. Better to image processing and all. One person, it is arised by one person also. Like what is the best method for the object detection in the smart environment? So I think that machine learning algorithms will not be working out for the object detections and all these things. So better to go ahead with the deep learning CNN model will be good for the object detection. I can say to you also. So preferably you can go for the deep learning model.
Thank you, madam. Thank you, ma'am. But any application is example is available, madam, with you? Means I am asking practical example or practical projects or any idea. Means if you
One
have
such is considered to be that traffic monitoring system. Traffic monitoring system is a one such example of this video surveillance or something like that.
Okay, madam. Thank you. Thank you very much.
Actually, one of my colleague was doing that. They have really implemented in the toll gate of some places in Chennai, and they assessed number of vehicles which are passed, and the number of vehicles, number of cars, number of cars or two wheelers, whatever it is. Which is crossed over there time by time, so that we can easily find out the what time it is totally peak and what time it is totally less traffic. He or she has done with the help of the CNN model.
Thank you, madam. Actually, anomaly detection also we can do that.
Yes.
Thank you, madam. Thank you very much, madam. Thank you for your session also, madam.
Thank you so much.
Madam, there is one more question in the chat box, madam. If someone is not from the computer science background, and if they wish to start with machine learning, so from where it should start as a beginner?
Where should you start in the sense? What the question is that if someone else is not from the computer science background and wishes to start with the machine learning, so from there we need to start from the machine learning. Better, you need to start the machine learning models with the different types of the data which is available. Like we have a different data, real data, nominal data, ordinal data, categorical data, many data, it is interval data, many data it is available. First you understand the data, then check with what are all the algorithms, what are all the categorization of the machine learning algorithms which are available, and which are all the algorithms are suitable for that particular type of a data, that you need to check it out. So if you find out, so first start with learning the type of a data, then go for the types of the machine learning algorithms. Later on you start implementing in the Python. Preferably Python is a inbuilt functions which are available for the machine learning applications, so that you can learn using the Python packages and get that idea.
Participants, any questions?
And one more thing, the IBM Watson is also having some models. If you have a permission to do with that IBM Watson, that you can apply all the algorithms which is available in the machine learning. Only you need to give the data set. Only you need to give the data set that will be executing all the models in that machine learning and give you which model is better for your data set. Which model is giving a most accurate result also it will be giving you. If you get the chance of working it, you can explore it.
Any more questions, participants? Okay, ma'am, we should officially close the session. Before that, Meena madam wants to say thanks to you, ma'am.
Ma'am, good afternoon, ma'am.
Good afternoon, ma'am.
Ma'am, thank you, ma'am. Thank you for your valuable speech. Kindly share your presentation to our mail ID, ma'am. That will be helpful for the participants for their exam test purpose, ma'am.
Oh, sure, ma'am. Sure, ma'am. Where should I share that, ma'am?
You just send to my mail ID, ma'am. I put
Okay,
it in
okay.
the Google Classroom. Thank you, ma'am. Thank you. Thank
Okay,
you.
ma'am. Okay.
Thank you,
okay,
ma'am. Thank you so much.
Thank you. Shall I leave, ma'am, now?
Yeah, thank you, ma'am.
Okay, thank you.
Okay,
Thank
ma'am.
you,
Thank you, ma'am.
participants.
Thank you, ma'am.
Okay,
Thank you,
bye,
ma'am.
bye, bye.
Thank you. Participants, you can all leave. We have already posted around 5 to 10 times of attendance link. Okay, you can make use of that to fill up the attendance link. And the next session starts by 2 p.m. You can all come and join by 1:50 p.m. Thank you, participants. You can all leave now. Thank you.